So for formulation of differential equation, there is a limit for a particular kind of function if the function is in this format: plus minus b e raised to power x, and there is the power of exponential have some multiple in front of them. So its differential equation will be of how much order? First order or second order? There are two arbitrary constants.
A and B.
Yeah. Second order differential equation will be there because there are two arbitrary constants. That's why. So its arbitrary, so its differential equation will be represented in this manner: plus mn y equals to 0. So this is the differential equation for these kinds of functions. Okay, so this is just one addition of short formula or short like this. We can call this as a result, which we can remember for solving these questions in a faster way. M and N was a prefix, was in the multiple of X. Okay, so is this clear?
Yes, sir.
Let's solve some examples. Example, given function minus 11x plus b e raised to power minus of 3x. So according to our trick, the differential equation should be minus m plus n. What is m and n? Minus 11 and minus 3. So what will be minus 11 and minus 3? Minus 3?
14.
Yes, minus 14 into y dash plus mn minus 11 into minus 11 into minus of 3. That will make it
Plus 33.
plus 33. Good. Into y should be equals to 0. So this should be the case. Now let's prove this. So in the exam, you can just go for this answer. 40 y test plus 33 y. So in just one line, you'll be able to find out the answer. You will just see the options and take the answer using this formula. Now we have to solve that. So y test will become a e minus of 11 into 11x into derivative of minus 11x, that is minus 11, sorry, minus 11 only, plus b e raised to power minus 3x, derivative of exponential function remains the same, into the derivative of minus of 3x, which is minus 3. So y dash now becomes minus 11a e raised to power minus 11x minus 3b e raised to power minus of 3x. Now differentiating on both sides with respect to x once again. So minus 11 will get multiplied by minus 11, it will become 121 a e raised to power minus 11x. Minus 3 will get multiplied by minus 3, it will make it as b e raised to power minus 3x. Any doubts?
No, sir.
Yeah. So this is our y double dash. Now y dash was this and y is this. So let's now solve for this and prove this whether it is right or wrong. So y dash, let's write y dash plus 14 of y dash. So 14 will get multiplied by this. So minus plus minus 14 into 11. It will be 154, right? Plus minus minus 14 into 3.
42.
Yeah, plus 33 of y. 33 of y. So 33 a e raised to power minus 11 next, plus 33 of b e raised to power minus 3 of a. So this is what, this should be 0. Now let's solve for this. 121 minus 154. Basically 121 plus 33 will make it as 121 plus 33.
154.
Yeah, 154, and it will cut, it will become 0.
0.
The coefficient of this. Same goes for this 9 plus 33 will make it as 42. Will cancel this. So everything will be cancelled and remaining will be 0.
0.
So that's why this short form, this short observation, this result works, and it will save our time.
Okay.
Yes. Now let's discuss about the solution of differential equation. Now for the formulation, what we were doing earlier, um, for formulation, what we were doing earlier is that there was some function given. There was some equation given, sorry, there was some equation given, and we were differentiating it as many times as the arbitrary constant it is having. So now for formulation of any differential equation, sorry, now for the solution of any differential equation, the situation is that we have already given a differential equation having dy by dx or first order or second order. Now we have to get from that differential equation to the equation. Okay. So earlier what we were doing, we were making an equation to a differential equation by doing differentiation. So, so now from differential equation, from first order in our syllabus, there are first order and of first degree differential equation solution. From like of these differential equation, we have to make the equation back. So for that, what we have to do now? Integration.
Integration.
Yeah. So solution of a differential equation, any relation correlate connecting the variables of an equation y and x and not involving the differential coefficient, coefficient as in dy by dx, such terms, such that this relation and the derivatives obtained from it satisfy the given differential equation is called a solution of differential equation. Okay, so that will be called as a solution of differential equation. Basically, any equation having variables obtained after integrating after integrating the differential equation, and it must not be having derivatives or differential coefficient as it is mentioned. So is this clear what we are going to do?
Yeah, sir.
Solving differential equation. Now let's move ahead. General solution. So we can find the solution of any differential equation in two manners. It can be general or it can be particular. General being general and particular being particular. Now general solution will have arbitrary constant. The solution which contains a number of arbitrary constants independent. What is it? The solution which contains a number of arbitrary independent constants equal to the order of differential equation is called the general solution or complete primitive of the equation. If the same general solution is the arbitrary constants are eliminated by using some result, then the solution will be considered as particular solution. Let me read the definition. The solution obtained from the general solution by assigning particular values to one or more of the arbitrary constants are called particular solution. What we are doing is basically we are integrating. So we know whenever we integrate any function, so after integrating, it has constant of integration. So if there is a constant of integration, this will be known as general solution. And if we have eliminated somehow this constant of integration, now the result will be known as particular solution. Okay, you'll be more clear after seeing this example. If you consider there is a differential equation, simple dy by dx is equal to y. So the general solution will be what? Dy, use different pen. So the equation will be solved. Let's take y to y and dx. There's no x. So after integrating, what we can write is y is equals to, ln of y plus ln of c is equals to x. So the constant we have written it combined. Now ln of c into y is equals to x. Now we can write it as cy is equals to e raised to the x when the log will go the right hand side. So and c can be written here also. We will change from small c to capital C. So basically this is the solution, which is having a c, which is an arbitrary constant. So that's why it is known as general solution. Is it clear what is general solution?
Yes, sir.
Now, if it were a condition that we had an initial condition in the question that y of 0 is equals to 2 means whenever we will substitute x for 0, then the value of y will become 2. So now we can now substitute the constant. How? That we have the function. So y, which is now 2. Okay, 2. C, which we do not know, e raised to power x is 0. So now 2 is equals to c, e raised to power 0 becomes 1. So 2, c becomes 2 now. So now our function will be y is equals to 2 into e raised to power x. Now this function do not have any arbitrary constant, right? So now this function, this solution will be known as particular solution. So it's particular. Understood?
Yes, sir.
Generated by Copilot. Different forms of first order and first degree differential equation, and we have to discuss this only as per our syllabus of UPSC and DA, that we have to discuss for the solution of first order and first degree differential equation. So first method to do it is by, if we are having a differential equation in which we can separate the variables, means we can write all the terms of x with dx, we can write all the terms of y with dy, then we can simply integrate on both sides with respect to x, and then we can solve further to have our differential. Clear?
Yes, sir.
Yes. So let's now move ahead and discuss an example. So this is the given scenario, dy by dx is equals to e raised to by x plus y. So it can be written in multiplication because of this property. I hope you are aware of this. So now let's try separating the dx and dy and dx terms. So dy term will be written with this, and x term will remain with dx. Now if you will try integrating on both sides, so its integration will become uh, this is basically e raised to power minus of y, so it will remain the same, and into the, so divided by the derivative of y, which is minus of 1, equals to the integration of ex plus c. So integration of exponential function will remain the same. Integration of uh, e to the x, no, sorry, differentiation of e to the x will also remain the same. So now let's try matching with the options. So now what we can write here is e raised to power minus y. So this is negative sign, so we can bring it to right hand side. You can write it as like this. So this is matching. There is also negative sign with this. So this is matching our option number B. How? We can we can keep this. We can keep the e term, y term on the left hand side. This is how it will match our option. Okay. So after solving, we have to just look for the option so that we'll have some idea. And also the options also help a lot in integration. Clear?
Yes.
Okay, so this was a solution. Now there are some differential equation which can be reduced to become variable so that their variables can be separated. Now let's say for this particular differential equation, we cannot separate the we cannot directly separate the variables here, like y and x to the dy and dx. But now what we can do here that we will put x plus y is equals to t, and after integrating this on both sides with respect to x, it will become 1 plus dy by dx is equals to dt by dx. So dy by dx value become dt by dx, and now y will get substituted from this. So it will become dy by dx is dt by dx minus of 1 is equals to t. So now this will become dt over dx equals to 1 plus t. So now t will be, this term will be written with dt and dx will remain. So now this is a variably separable differential equation. Okay.
Yes, sir.
And even if there is dy by dx and there is a function having x plus y, then also we can do the same. Let's discuss with an example. Now this example is having same what I have written here, that there is a function of having x plus y. So the function itself is saying let x plus y is equals to t, and on differentiating both sides with respect to x, this becomes, now the value of dy over dx becomes dt over dx minus 1. So now the differential equation becomes dt over dx minus 1 equals to cos of t. Now taking the one on the right hand side, changing the sign, and now trying to write dt terms together. Now this is dx. Now we can try integrating this term. Okay, integration of this and this. Integration of right hand side is very simple. This will simply become x plus c. Now, when it comes to this term, so now let's think for some solution. dt over 1 plus cos t. So we can refer to some of the examples which are written here, that the answer is in sine terms, tan or cos. So if we directly think for a solution, if we try to substitute 1 plus cos t is equals to some other variable, the derivative of that will become, one's derivative will become 0, derivative of cos t will become sine of t, which is not here, minus sine of t, which is not here in the given function. So we'll have to think something different. And there's also one formula, 1 plus cos t upon 1, sorry, that is like this. That is this cos square of x minus sine square of x, something like that. And also cos of 2x is equals to 1 minus tan square of x upon 1 plus tan square of x. Now we are thinking that how we can solve this integration further. Yes, 1 plus cos x can be written as 2 cos square of x by 2. How? That this can be written as, this is the formula of cos of 2x. This can be written further as uh, 2 of cos square of x minus 1. So 1 plus cos 2x will become 2 cos square of x. And if we halve the angle, the formula will become like this. Okay, clear how we have written this?
Yes, sir.
Yeah, so same goes for this. Same goes for here also. Let me first clean it. So now what we can write dt over 2 of cos square of t over t by 2. So now it has become a simple integration. We'll take 1 by cos is sec, right? So it will become sec square of t by 2 into dt is equals to x plus z. So now you can understand how this formula has helped us, how this option has helped us to think about that there can be some half angle formula, and we have done so. Okay, so the integration of sec square of x is 10x plus c. So half into 10 of t by 2 and divided by the derivative of t by 2, which is half. So half cancels half, is equals to x plus c. So now substituting back the value of t, which was this, 10 of x plus y by 2 is equals to x plus c. Now this c option has become our answer. Clear?
Yes, sir.
Great. So let's move ahead. Move ahead. The solution is also like this. Homogeneous differential equation. Okay, I feel like we should solve more of questions of variable separation method. Okay,
Okay, sir.
example, you have to solve dy over dx x square into e raised to power x plus y plus x e raised to power y. So let's try to separate the variables. And this can be written as, let's take e raised to power y common, x square. This will become e raised to power x plus x simply. Are you able to understand that? How have I written so?
Sir, could you repeat?
Yeah, this can be written as e raised to power x into e raised to power y. So now what I have done is I have taken e raised to power y as common. So
Common.
when this term will get divided by e raised to power y, this will cancel and the remaining will be written here. And plus this will cancel, e raised to power y will cancel this, and the remaining will be written here. Clear?
Yes, sir.
So now trying to separate the variables, it will be an easy job for us. Now let's integrate on both sides. This will simply become e raised to power minus 1 into divided by the derivative of the power differentiation of this x square ex dx plus differentiation of x square by x is simply x square by 2 plus c. Now the differentiation of this will use Eilert formula. You know what is Eilert? Just tell me the acronym.
Sir.
I stands for what? No problem. Give it a guess. If you don't know.
Um, Integration.
Inverse trigonometric function,
Okay.
logarithm function,
Ah,
algebraic function, trigonometric function.
exponential.
Good. Exponential. So here, this is exponential function. This is algebraic function. So this should be our first function. So first function into integration of second function minus integration into derivative of first function into integration of second function into whole integration. Are you able to understand that? How have I written so? Using this formula.
Hmm.
So now integration of e raised power x is simply e raised power x, no use. So x square e raised power x minus 2x e x into dx. So x square e raised to power x to common x e raised to power x dx. Now again there will be use of islet. So again this is algebraic. This is integrative. This is exponential function. X square e raised to x minus 2 bracket to x integration of ex will become this only integration of and derivative of this integration of ex. This will remain as ex only. So x square e raised to power x minus 2 e raised to power x common x minus 1. Now taking e raised to power x common x square minus 2 of x plus 2, and this is the integration what we needed. So going back, writing and adding the whatever integration what we got, e raised to power x into x square minus of 2x plus 2 and plus the remaining. So this is our answer. Simply. Clear?
Yes, sir.
This is our answer now. Digital India. So let's discuss more examples.
Okay.
By the way, do you understand Hindi?
Sir?
Do you understand Hindi?
Yeah, sir. Not a lot, but yeah, I can understand Hindi because I was in Goa for 2 years.
Great. So this is our example. Now, if we will try to separate the variable here, we will not able to do so because of these numbers added. Okay. So now what we'll try is that from simply seeing and watching, we are able to see that we are having a pattern that if we will take negative here as common, so it will become x minus y plus 4 divided by x minus y minus 1. So now this there is common variable in the whole function. We can directly substitute x minus y as t. So this will become dy over dx equals to dt over dx. Now dy over dx has become 1 plus dt over dx equals to dy over dx. So now this will be 1 plus dt over dx equals to minus of t plus 4 upon t minus 1. So now let's take the 1 on the right hand side. So what will happen? That 1 will be in negative here. So now minus t plus 4 minus of t plus 1 upon t minus 1. This will become 5 minus 2t upon t minus 1. Right?
Yeah. Prime Minister.
Yeah.
Yes, sir.
Have we done any mistake?
No, sir.
Yeah. Yes, we have. Yes.
Yeah.
1 minus dy over dx is equals to dt over dx. So for finding the value of dy over dx, it will have a negative sign here.
Okay.
So this is negative, this is negative. Now further, so we can write dt over dx as is a 2t minus 5 upon t minus 1. We have removed the negative sign. Now let's try to separate the variables. We will simply bring the all of the t terms to the left hand side, and dx will be isolated in the right hand side. So 2t t minus 1 upon 2t minus 5 into dt is equals to dx. 2t minus 5 upon yes, t minus 1. Yeah, so we can simply integrate it over here, and for this we'll have to do something. So t is there also, and it is like visibly it is a less term. Let's try to make 2t minus 5 in the numerator, and then if the t gets like eliminated from the numerator, we'll be able to find out its integration easily, like by taking log 1 by x. Integration is log. So that's how I'm thinking about it. So let's first write 2t minus 5 and also minus that whatever we have written, and plus the remaining is there itself. Understood? How have I written so?
Sir.
That I have added, and this will simply become x plus c. I have added and subtracted the same thing, so it will have nullify effect overall. So now let's separate this, and we can write integration of 1 minus, and this will become 5 minus 1, 4 plus. So this will become 4 minus of t up over 2t minus 5 into dt is equals to x plus c. Clear?
Yes, sir.
Okay. So, but still we are not able to eliminate the t. Why? Let's try making this as 2t. If this will be 2t, then we'll be able to eliminate the t from the numerator. So let's try it over again. So how we can make it 2t?
Multiplying by 2 or
Yes.
multiplying by.
Let's multiply 2 in the numerator and 2 in the denominator. Now it is more half into, so 2t minus 5 and plus 5 minus 2, whatever is there. Now we will be able to solve this easily. Half this one plus 3 by 2t minus 5. Now whatever we have thought, things are getting materialized, manifested solution. So yeah, now this will be an easy integration to do. Half into integration of 1 will simply become t, and integration of this will become plus 3 into ln of 2t minus 5. Yes, it's equals to x plus c. Okay, so let's try to simplify the answer. 3 ln of 2t minus 5 is equals to, we are bringing the 2 on the right hand side, 2x plus 2c. So simply we can write it as this only. But t has some substituted value. So what was t? T was x minus y. T was x minus y. So let's bring the t to x minus 2y minus of 5 is equals to 2x plus 2c minus of t. So x minus y was it? So this will become, so x plus y plus 2c to 3 of ln 2x minus 2y minus 5. So this is our answer. Clear?
Yeah, sir.
Any doubts?
No, sir.
Simply what we have done is we were able to spot a common variable in the function. That this was a function of two variables, and we were able to make the function of in this format, है ना? By like making a common variable. We will also understand further that if we are not able to do so, that what if the sign here is this, then we will not be able to make common variable from this given differential equation. So for that, now we will discuss about homogeneous differential equation. Ready?
Yes.
Homogeneous differential equation. So basically, these are differential equation of the form f of x. There is a function of in two variables in the numerator, and there is also a function in those same two variables, but the function is different in the denominator. So these are two homogeneous functions. Homogeneous function means they have a homogeneity in their degree. They have same degree. Homo means same, and geneous means of the same category. So they have same degree is said to be homogeneous differential equation. So here, if you'll understand this example, if you'll solve dy over dx, it will become minus of x square minus of xy divided by y square. So the degree of this is 2. The degree of this is 1 plus 1 of, like we are discussing about the degree of variable. So degree of x and 1, and this is 1, this is also degree of 2. And here is also degree of 2. So basically this is a homogeneous differential equation. That's how we test it. One more method is that if you are able to if you are able to represent the function as y over x or x over y, so so we can apply this same method of how we are what we are going to discuss further. Okay, so same here we can also do so. How? If we will take, let's say, x square common, so minus 1 plus divided by x square, so cancel 1, so it will become minus of y by x, the y square divided by x square. No, we have taken common. So this I'm not dividing anything. So we have taken common. So x square will be written downwards. It will come down, and now it can be written as this. So minus 1 minus y over x, y over x whole square. So now this has become a function of y over x. Okay. So this is also a symbol of being homogeneous differential equation. Clear?
Yes, sir.
So what we'll simply do, earlier we were having substitutions like these. Now we are having in fractions. So we'll consider this as equals to t. Y will be equals to tx, or we can also denote it as v as given in the NCRT or what we have culturally studied in classroom. It is up to you. So y over x t, y becomes y is equals to tx. Then the difference, then after taking differentiation on both sides, it will become dy over dx equals to t plus x into dt over dx. Okay. Now further we'll do this or that, and we'll make the function in terms of t, and this will reduce the function to variable separable differential equation. We will be better understanding when we will discuss examples. Clear?
Yes, sir.
Please observe the slide.
Okay, sir.
Clear?
Yes, sir.
So let's discuss this solution. Sorry, this example. So the example has the solution of, we have to find the solution of x plus y dy minus of x minus y into dx. So we can, in this equation itself, we can understand that we can make it a function of x plus y. So let's try first writing for solving for dy over dx. It will become x minus y over x plus y. Should I explain? Because we are simply taking this to right hand side, and this the function, the differential equation will become like this: dx sent to the left hand side, x plus y sent to the right hand side. That's how we have written. So clear?
Okay, yeah, sir.
So now we have this equation. So the degree y 1 1 1 1 simply. Otherwise, we can also check it as when we'll replace y for y is equals to lambda x. Okay, then what should happen is that the function should become lambda into raised to power x. Now lambda raised to power n, and the function will remain the same. Sorry, uh, y has become this. Function should become like this. Okay, so this is also one more test, and we can also simply by our eyes we can see that whether we will be able to make this function in the terms of y over x or not. Let's try to make it such, taking x common. So 1 minus y over x divided by x common again, y over x. X cancels x. Now this is a function of y over x, right? So this is a different homogeneous differential equation. Now what we can do is we can take this as, we can assume y over x is v, right?
Yes, sir.
So solving it further will make it this, will give us this. After differentiation, it will become, right, using the product rule. Clear or not? Like if we take the first differentiation of this into v, differentiation of this is 1, then simply this x and differentiation of v is this. That's how we have written dy over dx, right?
Yes.
So dy over dx has become this now, 1 minus v upon 1 plus v. So simply x into dv over dx. Now 1 minus v upon 1 plus v was yes. So let's bring the v on the left hand side. It will make it as 1 plus v, 1 minus v to minus of v minus v square. Clear?
Yes, sir.
1 minus 2v minus v square upon 1 plus v. So yes, this is x dv over dx. Now separating variables will be very easy. 1 minus 2v upon v square upon 1 plus v dot dx over x. Now we'll integrate and simply solve for the differential equation, right? So we have only 5 minutes left. So this is how it has done. Also, they have also let it y over x as b. So in this, they have skipped some steps. And they have avoided writing in the form of y over x and checking for whether it is homogeneous or not, because it's a book. So dy over dx simply done. Then integration, it will be simply solved after. And they have also skipped a step here. They have simply what they have done is they have let t is equals to 2 minus 1 plus v whole square. After this, they have differentiated on both sides with respect to v. So this will become dt over dv, and differentiation of this will become 0, then minus of 2 into 1 plus v. Yeah. Sorry. Okay. So dt over dv is becomes the differentiation of this. So x square differentiation is 2x basically into differentiation 1 plus v is also 1. So now this is the case. Now in the numerator there is 1 plus v. So this is very simple. Now dv will become dt over minus of 2 1 plus v. It has become dv. So I will substitute for dv 1 plus v will be cancelled and minus of half will be in the multiple, and whatever is remaining it will be written as integration of dt over t. So logarithm of t, so t has back substituted. So they have like considered that you have already studied integration, that's why they have not solved for it. Okay. Now further they have simply again back substituted the value of v, which is y over x, and they have simplified the expression, right?
Hmm.
Understood. And there here also what they have done is uh, there's a property. Now the n will be over the x, and back is also so minus half. They have brought it upwards, and logarithm. There's another property, log of m plus log of n is equals to logarithm of m into n. So they have multiplied the x and c here, and I guess there is a misprint also. Here should be logarithm of xc, and here also should be xc. Let me check the. Hmm. It is mistake. Yes, it is a mistake for sure, because logarithm of x. Then they have just forgotten about it, and they have also not mentioned it in the left hand side. So it's a mistake completely. They have missed this term. So this is how it is solved. Is this clear? Any doubts? Any doubts?
No, sir.
Okay, so we have discussed about homogeneous differential equation, and in this there is a another scenario in which we can modify the or improvise whatever the function is given to us, the right hand side, to make it as homogeneous differential equation. If there is some dvida like this, there are some speed breakers like these constants are adding, and how we can make the function in terms of y over x or x over y. We will discuss it in tomorrow's class. Any doubts?
No, sir.
Great. Any review, feedback, suggestion?
No, sir. Only one doubt. Like after this differential equation, what will be the next chapter, sir?
Okay. So I'm thinking to go over to go like to defy what the syllabus is given to us as per the VIZHI awakening test academic academic officer.